All right, guys, I just wanted to go through and make a quick little video to help you out with this activity if you guys are at home in class today. So we're gonna make some more motion or some more position versus time graphs, which we've been working on. You guys are gonna make some position time graphs based on like what a certain situation here that is being presented on these problems. Okay, so certain situations presented here, you have to create that what the map or what the graph would look like for that. Okay, and then down at the bottom, we're going to build one of these motion maps. Okay, for that, after you make the graph, then you're going to build a motion map for that. So it's on this class kick assignment. You're going to open up this simulation here to do that. Now on this simulation that we got right here, you can move this kind of guy, or you're gonna move this guy around, and he's gonna this guy's gonna make your map for you. So what it says to do on the directions, you're gonna have this moving man do that work for you. Okay. Now I want you to hit charts up at the top here, and that way here you get these graphs. Now we only want the position graph. So the velocity one, you can click the minus sign. The acceleration one, you can click the minus sign. And now we got just a position versus time graph. Okay. And really we only want to use the positive numbers. Okay, so we're going to have positive time going this way, and we only want to use the positive part of this. So we only want to move this. So guy's at 0 right now. We only want to move him to the right from here. Okay, let me just kind of play it, and we'll see what happens, with the guy first. So he's sitting there as flat, and then when I move him, he starts, following his position. Or if I stop him, if I turn him around, I'm moving faster, and then I can click stop on that. So this trace the path of his position right over those course of those couple seconds. Okay, so that's what you're gonna try and do that with these. You're gonna do that with the moving man. Okay, then you can click reset each time, reset the settings. You have to then close those other graphs again. And you want to close those other graphs just so you have a bigger screen here. So what you're going to do with the motion or the moving man is read the statement here and then move the man in that direction. Okay? So if we look at this, right, it says using a lab partner and a whiteboard, right? Instead of using the lab partner, you're using the moving man. Make a position time graph with a constant positive slope and a y-intercept of 0. Okay, so what does a y-intercept of 0 means? Oh, it's going to start down here. Right, it means it's going to start at 0, across that y-intercept at 0. And then we want something that creates a constant positive slope, so something in that direction. So what does the moving man, what do we need to do with the moving man to get it to start at 0 or have a y-intercept of 0? Oh, it means, hey, he's starting right here at he's starting right there at 0. So actually we got that first. So that first y-intercept is 0. We got that. Okay. Now we need to create a constant positive slope, right? So positive means like up, right? So to get it to go up, we need to move him. Oh, looks like just away from the starting point. So he needs to move away from the starting point. And constant means we want it to be a nice straight line. So we want the moving man to go at a nice, like the same rate. Okay, so I'm gonna hit play, and then I'm gonna just move him kind of in that direction to the right. Let's see, I'm gonna shrink this a little bit, yeah, because you don't need that many seconds. Yeah, we don't need we can do this in shorter amounts. I'm going to restart that. Let me try that one more time. I'm just going to reset that. But you guys get the idea, right? I'm going to zoom it in because we don't need that many seconds. So I'm going to start it, and he's going to move to the right, and then I'll stop. So it looks like we got, we got that positive, we got that constant positive slope. So that's the part of the graph we want to focus on here, right? Because it takes a second from when you hit start to like where I started moving him. So that's where it was flat when he was just waiting there. And then at the end, when I let go to click the button, it got flat again. So we're going to ignore those parts. And really, our graph is just this straight line going up. So I'm going to draw that. Okay. So that's my graph, constant positive slope, right? And a good sketch is fine. Now, the next thing is to take that and make a motion map of that. So this motion map, okay, you guys watched the Ed puzzle on this the other day. The motion map is looking at the y-axis, but putting it horizontally. So over here is like position 0. Over here is position 10 meters, 0 meters, and 10 meters. So what we're going to do is we're going to put little dots and little arrows to show where that moving man was at those points. So at time 0, he starts right here, right at 0. So you just put a little circle. Started at 0. And then we moved, we moved like away from the 0 point, right? So we're going to put an arrow moving away from the 0 point. Now, he moves the same rate every time. So what I need to make sure I'm doing is putting, about the same amount of space between my dots and about the same length arrow. That one's a little too big. About the same length arrow to show that this guy at this point, delete that last one, that one's not great either. Okay, to show that this was a constant velocity, or is covering the same distance. Like if you want to say this is 1 second, this is 2 seconds, this is 3 seconds, this is 4 seconds, this is 5 seconds, right? The motion kept being away from the start, and it kept going at the same speed. So it should be the same distance and the same arrows. Okay. Now, if the moving man maybe started at a point other than 0, if he started somewhere else, then your first dot's going to just be somewhere else on the map. Okay. Or if it went back the other way, your arrows would point in the other direction. Okay. Or maybe he loops, goes one way, and goes back. Okay. But that's how you do the first one. Okay. So you guys have that one down, and you can feel free to copy what I got onto slide 1 on your class kick assignment here. What you need to work on then is the next. Looks like there's 7 more slides. Okay, using the moving man, and yeah, using the moving man. Create the graph first, and then do your best to make the motion map. Okay.